Hey, fellow problem solvers, Colfax Math here. Today we're working on Math Test Success. It is a 25 chapter book with 25 corresponding videos. The idea of this book is completely free online. You can just download it. It's for me to work through the book with you. So the way you want to do that is you want to download that free book at mathtestsuccess.com. Have that book out in front of you. You're going to watch the video, kind of fill in the blanks, take notes, and then there are practice problems and a test at the end. Pause the video, do the practice problems before I do them, unpause the video, and then watch how I do them. So we're going to work our way through this so that you could be successful on any math test. Another thing that's new is I have memberships for my YouTube channel. With that, you could join just to support the channel, support the videos. It will also give you earlier access to the videos. All right, with that said, let's go ahead and get started on Chapter 15, Graphs and Coordinate Geometry. No matter what, you got to have paper and pencil out in front of you, even if you haven't downloaded the book. So today, all of this stuff is based on this idea. It goes all the way back to first grade and learning to count on a number line 0. Going this way is positive, this way is negative. And then after a while, you call this x. And then you add a second axis to that. That is your axis y. And this becomes your Cartesian coordinate plane. Horizontal axis is always x. The vertical axis is always y. This point right here where they intersect is the origin. Its coordinate is 0, 0. And the axes are split into 4 quadrants. You always start right here on the x-axis, rotate counterclockwise. So this is your first quadrant, your second quadrant, third quadrant, and fourth quadrants. And then if you have a coordinate, you would go over, say, 3 and up 4. This is a coordinate. It is always x first and then y. You could have multiple points on your Cartesian coordinate system. You could connect those points with a line segment. You could find the length of that segment. You could find the slope of that segment. There's a lot of math on any standardized test that goes back to these ideas. So again, here are the 4 vocab words you have to know. Now let's talk a little bit more about plotting points and slope. So scroll up here a little bit. So again, this is a Cartesian coordinate system. Let's only work in the first quadrant right now. Again, y is always vertical. When you have a coordinate on here, let's say I'm over 5 up 2. It is always x before y. You got to go over to the elevator before you go up in the elevator, or alphabetically, x comes before y in the alphabet. Therefore, this value is always x before the other value y. What I am saying here is this is actually a triangle, and it has a horizontal component of 5 and a vertical component of 2. Okay, so here's an example. Plot the point 3, 2. Well, that would be over here, say 3 up 2. There's a coordinate 3, 2. Slope. Let me go back to my original one. The slope of this, slope is defined with the letter m. It is slope. It is always rise over run. And since rise is vertical, it is always going to be the difference in the y values over the difference in the x values or the run. So that's how you calculate slope. So let's take a look at an example here. Let's say I have 1, 3. I am over 1, up 3. There's my first coordinate. Then I am over 4, up 9. That is my second coordinate. So I could write that ordered pair as 4, 9. This ordered pair as 1, 3. I could use that equation of slope, rise over run, the difference in the y values, 9 minus 3, 6, 9 minus 3, over the difference in the x values, 4 minus 1, 3. I reduce that fraction to have a slope of 2. What that 2 is saying is for every 2 I rise, I run 1. 2 I rise, I run 1. So I run a total of 3 and I rise a total of 6. Okay, here's another example. Find the line passing through those 2 coordinates there. You could draw it all out, or now you could just use the equation. A big part of math is kind of using the graphs to get the concept down in your head and then move to algebraic solutions. So I want to do -5 minus my other value 5 over 3 minus -2. -5 minus -5 is -10. The way I do these minus and negative, I think a guy on a diving board, he jumps up off that diving board, boom, breaks through the surface of the pool. Minus and negative is plus, so that works out to be 5. This is equal to -2. Still a slope, it's still a rise over a run. It is negative, saying I am going down. It's a negative slope. That's how you do it algebraically, but I could do it graphically too. I am over 3 up -5, so that's down here in the 4th quadrant. Then my second coordinate, this one right here, is over -2 up 5. So that coordinate's right there. What is the slope of that line? Well, I rise -2, run 1. Rise -2, run 1. Rise -2, run 1. Or I rise a total of -10 and run +5. They are all ratios. They are all equivalents. Because it is a straight line, that slope will be a constant. So you could talk about it as -100 over 50 or the reduced -2 over 1. All right. With that said, let's move on to distance between points. With this, we need to know the Pythagorean theorem. First thing about the Pythagorean theorem is it only works in right triangles. A right triangle has a 90-degree angle. That little box is saying those 2 lines are perpendicular. Perpendicular, 90, square, all mean the same thing. If it is a right triangle, then the Pythagorean theorem works. Or the converse, if the Pythagorean theorem works, then it is a right triangle. Okay, on the Pythagorean theorem, this has to be a leg, this has to be a leg, this has to be the hypotenuse. In a right triangle, there is only one hypotenuse. It is always opposite the right angle. And then there are 2 legs. So one leg squared plus the other leg squared equals the hypotenuse squared. So if this is, say, 3, this is, say, 4, what is C? Well, I would take that, A squared plus B squared is equal to C squared. One equation, one variable. I have to solve for that variable. 3 squared is 3 times 3, 9. 4 squared is 4 times 4, 16, equals C squared. C squared is equal to 25. Take square root of both sides. Square root and square cancel. If I do that to the right, I do it to the left. So C is equal to the square root of 25. What times itself is 25? Either a 5 or a -5, right? -5 times -5 is 25. However, length of a side cannot be negative, so I discard that one. So my answer is, if one leg is 3, the other leg is 4, the hypotenuse is 5. It's a really common triangle that works on the Pythagorean theorem with integers. A lot of people call it a 3, 4, 5 triangle. Use it in construction all the time. Say you're building a house and a fence off of that house. You want to guarantee that thing is square to the house. If you measure 3 feet down there, 4 feet down there, and then you pull this hypotenuse till 5 feet, and this is 3, 4, and 5, then it has to be a right angle or a right triangle. Okay, here's another one. The leg of a triangle is 9, the other leg 12. What is a hypotenuse? So I draw my picture. Right triangle, 9, 12. What is C? 9 squared, 81, plus 12 squared, 144, is equal to c squared. 225 is equal to c squared. Square root of both sides is 15. C is equal to 15. It is the same ratio as the 3, 4, 5. That's why I was able to get it so quickly. Let's take a look at another couple of examples here. This one's a little trickier. The hypotenuse is 15 and the leg is 5. Find the other leg. I don't know what it is, so I call it B. Then I have 5 squared plus B squared is equal to 15 squared. 25 plus B squared is equal to 225. That's equal to 225. I'm going to subtract 25 from both sides. These are canceling. I get B squared is equal to 200. Square root of both sides, square root and square cancel. Now I need to figure out what the square root of 200 is. It is not an even number. It's not going to work out to be an integer. But I could simplify that square root, and that's the way you usually do it on any standardized exam. Your solution, if it was multiple choice, would be something square root something. So to simplify this square root, I'm looking at the factors here. It's made up of a 2 and a 100. 100 is made up of a 10 and a 10. I could keep going, but as soon as I have a pair, I'm done. So the square root of 200 is the same thing as 10 root 2. So side B is equal to 10 square root of 2. That's called an exact value versus a calculator value. I could enter that on my calculator, do all this on my calculator, but almost every one of these standardized exams will do these without calculator, so there's no calculator. So that's the Pythagorean theorem. Now we're going to take that bit and put it into the ideas of finding distance between 2 points. So let me graph this thing out right here. I am over 2, up 4, right? This is y. Then I am over 6, up 10. I have a point here at my first ordered pair, 2, 4. I have another point right here, 6, 10. That's this one. I connect those dots, and I want to find the length of that line. Well, there's a horizontal component of that line, and then there's a vertical component of that line. So horizontal and vertical will always be perpendicular. So then I could just use the Pythagorean theorem. That vertical component is 6. From 4 to 10, it's 6. And then that horizontal component is 2 to 6, or 4. So then I have one leg squared plus the other leg squared is equal to, I don't know what that is, so I call it C, equal to C squared. 16 plus 36 is equal to C squared. Combining these, 40, 52 is equal to C squared. Square root of each side. That and that cancel, I have C by itself. Right, it's going to be a little bit more than 7, right? 7, 7, 49, but let's simplify this. 52 is made up of a 26 and a 2. That's made up of a 13 and a 2. There's a pair of 2s. 1 comes out. No pair for the 13, it stays in. So what is the length or the distance from here to here? 2 root 13. There's a distance formula, but the distance formula is no different than just using the Pythagorean theorem. So we've gone over 3 big ideas. First idea is graphing on the Cartesian coordinate plane, ordered pairs, connecting those with lines or segments, our 4 quadrants working in positive and negative. Our second idea is finding the slope of that line. The slope of the line is rise 6 over run 4. So the slope of that line is 6/4 or 3/2. And then the distance, third idea is the distance between points. And that distance, we're using the Pythagorean theorem to find the distance is 2√13. Okay, let's move on to a little bit more here on graphing and points of intersection in graphing. So it's going to get a little more tricky here. We had systems of equations earlier, and we're going to look at them again. But we're also going to look at them graphically. So you might remember the general form for graphing from a previous chapter is y equals mx plus b, where that is slope and that is y-intercept. So if I want to graph these lines, I'm going to start there. I am going to put them in that form. So I'm going to do this one first, and I'm going to subtract 2x from both sides to get y equals negative 2x plus 7. I subtracted 2x from here, that canceled. I have to subtract it from there. So there's my first equation. Let's go ahead and graph this. This is a y-intercept. It intercepts the y-axis at 7. This is a slope. It's a fraction. From 7, I go down 2/1. Down 2/1. And my graph looks like that. So there's my red graph. Now let's try and figure out this graph right here. This time, I have a negative y. This is my roadmap. This is where I want to go. I want to make it positive, so I'm going to add y to both sides just to make it positive. That's going to give me x equals 2 plus y. Now I'm going to subtract 2 from both sides, and that's going to give me y by itself is equal to x minus 2. So here's my second equation, y equals x minus 2. It has a y-intercept of negative 2. This is a slope, no number there, so it has to be a 1. It's a fraction, so it's 1/1. From negative 2, I rise 2, run 2, rise 2, run 2. And my blue line looks like that. So now, first thing I've done is I've taken my two equations, put them in y equals mx plus b form, y equals slope intercept form, and I could see they intersect here in the first quadrant. I want to find that point of intersection. So the way I'm going to do that, let me erase this now, is I am going to do that algebraically. If I had a really good graph, like a perfect graph, I probably could do it graphically if they were integers. But now we're going to do it algebraically. And this goes back to that other chapter where we looked at systems of equations. I'm just going to transpose that over here and then add these two equations together. 2x and x is 3x. Y and negative y cancel. That's why I put them there. And then 7 and 2 is 9. Divide both sides by 3. Those cancel. And x is equal to 9 divided by 3 or 3. Uh-oh, don't want to do that. X is equal to 3. Now I can take that value of 3, plug it into either equation. I'm going to plug it into there. 2 times x, which is 3, plus y is equal to 7. 6 plus y equals 7. I subtract 6 from both sides, and I get y is equal to 1. I have a value for x, 3, a value for y, 1. That is an ordered pair x, y. And what I am saying is this value, this point of intersection right here, is over 3 up 1. That is a point of intersection. Again, you could do this multiple ways. One is graphically, and then the other is algebraically. And then even in the world of algebra, there are two ways to do that. One is substitution. We went over that on a previous chapter. Or the other is linear combinations, where I combine the two equations to solve. Okay, go ahead and pause the video and do example 2 right here. And try and do it without graphing and see if we could just get this right. Okay, So what I am going to do is I'm going to try and get rid of the y. So I'm going to take this and multiply it by 2 on both sides of the equation. That is going to give me 2x plus 2y is equal to 12. I'm going to combine those two to get 5x, my y's cancel, is equal to 20. Divide both sides by 5, and x is equal to 4. There's my first part of it. Take that value for x, plug it in here. 4 plus y equals 6. 4 plus y equals 6. So y is equal to 2. I have an x and a y. My solution in an ordered pair is 4, 2. Okay, move up a little bit more. This one might take some more room. Pause the video. Go ahead and do this problem. Unpause, watch how I do it. Here's a pretty tricky word problem. So I got to create my equations. The sum of two numbers, we'll call that x and y, is 15. Their difference is 3. So x minus y is equal to 3. Ooh, got to sneeze. I'm going to use linear combinations. X minus y is equal to 3. I combine these two equations, adding them together. X plus x is 2x. Y's cancel. 15 and 3 is 18. Divide both sides by 2. And x is equal to 9. That's not my solution. It is half of my solution. I take that value of 9, plug it back into my equation. 9 plus y is equal to 15. Subtract 9 from both sides. Y is equal to 6. It is again an ordered pair. My two solutions are 9 and 6. I could do this graphically as well. But let's double check this. These two numbers should add to 15. They do. They should subtract to 3. They do. All right, here we are. We're finally on the test, chapter 15. A lot of information here. Pause the video, work your way through this test, unpause the video, and then see how I did it. Okay, go ahead and graph these points. These are ordered pairs. I am over 2, up -3. There's my first point. -1, 4. There's my second point. Kind of out of room here. -3, -2. And there's my third point right there. So quadrant 1, 2, 3, and 4. Number 2, find the slope of the line passing through that. Slope again is rise over run. My slope is going to be my y values. 1 minus 7, -6, over 6 minus 3. That's going to reduce to -2. My slope is negative. It's a ratio of rise over run, -2 over 1. Okay, this one right here, we're going to use the Pythagorean theorem. This one, again, is slope. This one is length. So this one here, I have the coordinate -4, 2, and the coordinate 5, 2. Oh, it's a good thing I graphed it. It goes straight across right there. So the rise here is 0. The run is whatever number you want to put in there, 9. 0 divided by 9 is equal to 0. And that kind of makes sense, right? A horizontal line has no slope. That's what you'd expect. 0 divided by any number is equal to 0. The opposite of that is not true. 9 divided by a 0 is undefined, but we'll not leave it there for now. Number 4, find the equation of a line y equals mx plus b, where the slope is -2 and the y-intercept is 5. So y equals -2x plus 5. Number 5, graph y equals 3x minus 4. A little crowded here. I'm down here at -4. That is my y-intercept. From there, I rise 3, run 1, connect those two dots, and there's my line. Slope-intercept form, again, is slope-intercept, mx plus b. Let's move this up to number 6. This one right here is a little trickier. Find the equation of the line passing through 1, 5, 3, 11. So I need a road map. That road map is y equals mx plus b. I got to find slope first. That's going to be m. M is going to equal 11 minus 5, 6 over 3 minus 1, 2, and my slope is 3. I take that m value, plug it in here to get y equals 3x plus b. So I have y equals 3x plus b. I need to solve for my y-intercept b. I could pick either point. Doesn't matter which one I pick. I think in this case, I'm going to pick this one. I'm going to take that y value, plug it in for y. That x value, plug it in for x. That's going to give me 5 is equal to 3 times 1 plus b. I'm going to subtract 3 from both sides to get b is equal to 2. From my general equation, y equals mx plus b, I go to my specific equation, y equals m, 3x plus b, b is equal to 2. So number 6 is this equation right there. Oh, these two are tricky ones. You might see these definitely on a standard test. So I have a vertical line. Here my rise is whatever, 10. My run is 0. Anything divided by 0 again is undefined. There is no solution. So a vertical line has no slope. Horizontal line, like the last one, horizontal line is the opposite. I'm going to have rise is 0, run is say 10 or 20 or a million. 0 divided by 10 is 0. So what is the slope of a horizontal line? It is 0. The slope of a vertical line is undefined, and you say that with that 0 with the slash through it. Okay, number 9. Let me get a little more room here. On number 9, I have these two equations. I want to find the point of intersection. I need to combine the two equations. A lot of ways to do this, but I think I'm going to just multiply this side by 2 and this side by 2. That is going to give me 2y is equal to 2 negative 2x plus 8. So this equation multiplied by 2 on both sides is now 2y minus 2x plus 8. I'm going to add these two equations together. Y and 2y is 3y. 2x and negative 2x is 0. They cancel. Negative 5 and 8 is 3. Divide both sides by 3, and I get a value of y is equal to 1. Again, that's not my answer. That's half my answer. Now that I have that value of 1, I take it and plug it in here. And I get 1, which is y equals 2x minus 5. I add 5 to both sides to get 2x is 1 plus 5. Divide both sides by 2. Whoops, going too fast. Divide both sides by 2. And x is equal to 3. I always get like this at the end of a test. X is equal to 3. It is an ordered pair. X always has to come first. So your solution is x, y, the ordered pair, 3, 1. All right, last problem for this chapter. If you're still here, fantastic job. You're getting it done. That's what it takes. A lot of work, a lot of practice. Tickets for a school play cost $5 for students. So $5 for students and $8 for adults. If 200 tickets are sold, so the total number of student tickets plus the total number of adult tickets is 200, and the revenue was $13.40, so that means 5s plus 8A, right? The number of student tickets times the price of them plus the number of adult tickets times the price of them is equal to 1340. How many adult tickets were sold? So I have this here. This is an S. I need to solve my systems of equations. I could do it graphically or algebraically. I think I'm going to do it algebraically. I think I'm going to multiply this by a -5 and this by a -5. A lot of ways to do it, but that's going to give me a -5s, canceling with that. So that gives me -5s, -5 times A, -5A, -5 times 200, -1000. I add these two equations together. These cancel. 8A minus 5A is 3A. 1340 minus 1000 is 340. And then I divide both sides by 3. 340 divided by 3. 3 goes in here once. 0 once. Goes in here 3 times. 9 once 10.3. Doesn't quite make sense. So how many adult tickets were sold? We are solving for A here. I guess this is a capital A. Solving for A, so 113.3 adult tickets were sold. You don't have to find out how many student tickets were sold because the question is only asking for adult tickets. All right. Again, if you're still here, good job. I know you're working hard to get it done. This is chapter 15. Next chapter, chapter 16. New to the channel, think about subscribing. Go to that webpage, Math Test Success, if you haven't. Download the book. And, you know, the more you study, the more you practice, the better you do. Keep working at it. You'll do great on your standardized math exam. Thank you for watching.